See?
Trina, take pictures of work.
I literally can't.
Trina, look at that signature. That's mine.
Ew. There you
There's
go.
no mirror than that. Why?
Because I didn't see how you just started.
I just plugged in
No, I
zero
wasn't
and
reading
pi.
it. No, I don't remember
Not
any of
trusting
it.
you don't work. Not trusting. I plugged in 0 and pi.
I'm so confused.
You want to see my? This is my work. I wrote the problem and it's the 0 pi.
I agree with Kyle's 39. Yes, by the way.
Oh, we have notes.
Guys, something to keep in mind really quickly. I just started recording, but the problem is we just went over a homework question. We just went over homework questions. I started recording, but will the recording ever have the homework questions if I have people on board?
No.
So, you might want to, if you're absent, have someone you can text and be like, hey, can you take pictures of the homework I was done on the board today if we're going over homework questions. Does that make sense?
See.
For number 39, we're actually going to talk about how to take derivatives of polar equations at a later date, but it was, I don't know, I thought it was interesting you guys could figure it out right now. Long story short, if we want dy dx and we have an r equals f of theta, we need to make an x, we need to make a y, which he did with parametric, true? You can make x equals r cosine theta, y equals r sine theta. You can make an x, you can make a y, but then you need differentials of that x and of that y. But the only way to take a derivative is if you take it with respect to theta, because they're both based on theta. So you can take d theta of the x equation, d theta of the y equation. You have dy d theta, you have dx d theta, and it truly is as simple as dividing the two. The d thetas, in a sense, cancel out. In a sense. It gets harder when you go take a second derivative. We'll talk about that when the time comes. It's not quite as basic as you might think it is. But you can take y prime over x prime, dy d theta over dx d theta, and that does truly equal dy dx. So you divided the two. Well, here's a better way of writing it. I would change one thing with Kyle's. I would make it not dy d theta, I would make it d d theta of y. Of x, so that was the next step to getting dy dx, and then you took the derivative of, and the derivative of, oh wait, that's the division line? Yes. Oh, yes, this is the division. This is saying divide this one by that one. Take d theta of the y over d theta of the x, you will get h. Does that make sense? Yeah. And then did anybody of you guys, when you saw the whole slope of the polar, did you try to do it in calculator?
Probably. If it's, I use my
Change the mode
calculator.
in your calculator to polar.
I use my
Go to
calculator.
r equals and see if second trace has a derivative option. It does for function, right? You can take or find dy dx of a function first. Can't do over polar. Polar's trying.
Yes, I am.
Go to polar mode.
Yes, I am.
Go to r equals, which is y equals. And try second trace.
Yes.
There is a dr theta. Is there a dy dx though?
Yeah.
So maybe you could have used your calculator at this point since we did not cover it yet here. Because it says, I think, when theta is 0 and when theta is 1. Anybody else need queries number 25?
It's a masterpiece.
Masterpiece.
Is that 2th?
Oh, I didn't think that.
Or 2 plus H? 2 plus H.
Oh, not so well. Average rate of change.
Have you guys gotten to the example yet?
No.
I'm at the table of
Nice job, Christina.
Well-
I'm so proud.
Yeah.
You know?
contents.
Where's my calculator? There it is.
Why do you make a second line? You have a line right here. Why do you make a line
Should I
likes having more space.
Because mine is smaller.
Just wait.
See, it's smaller.
Mine's small too. Just right in two blocks. But you're wasting space.
Wait,
Stop judging, judge not, lest you be judged.
Miss Lee, are we putting anything in the DYDT part?
Yeah.
Okay.
One of those little like metal ball things.
You have a metal ball?
No, I need one. You know the ones that you
Oh,
can
those?
use?
Yeah, yeah.
Is it coaching check or something?
Yeah. I have one somewhere, but I don't know where it was. I didn't find it somewhere.
You had a cup with your name on it? Where'd you get that? Who gave you that?
Julia Minocchio.
No idea who that is.
Is she the...
Julia! No.
She has
She
like
played
brown
Brown.
hair.
Wait, maybe. Think
Curly
I know.
hair. She was friends with like Valerie Barrera.
Got it.
Is her hair brown?
Julia
She's the
Minocchio.
person I never remember.
JJ. She needs JJ.
Oh, yeah.
Oh,
Oh.
Julia!
Oh, now I remember.
She bought these for Sheldon and I, and she put our names on it. It was pretty fun. That was like her end of the year present.
I need to finish recording quick.
All right, so if you were stuck on number 39, just a quick heads up, you could have gone into, that's weird, polar. Boop, boop, boop. There is a lot that polar mode does not offer. However, you could have thrown in the equation, what was it? 1 plus
One.
negative 1, right?
Oh.
And when you went to graph it, ooh, I am not in Zoom standard, whatever I'm in. You guys should know what you guys should know what that graph is anyway, right?
It's
Because A and B is equal.
Oh, that's like cardio.
However, if you go to second trace, like I was talking about, there is both a dy dx option and a dr d theta option. These mean two very different things. Dy dx would be talking about the slope of the tangent line, change in y over change in x, the slope of the tangent line to the curve at that point. Dr d theta would be the rate of change of the radius with respect to the theta. Very different question. Yeah, no.
But A and B aren't the same. X negative 1 and 1.
Oh, I'm at the coefficients, we'll see.
Oh,
I'm at the coefficients are the same, not the sign.
that's the 1 and 1.
So I was thinking cardio.
So it'll still be a cardioid, because when sine is 1 equals 0, it's just going to be oriented differently because of the negative. Anyway, so you could have gone ahead, thank you, I appreciate it, and done dy dx, and you could have done dy dx at 0, would have popped it out for you, and then you could have also done it at pi. Okay, anyway, that's another reason why I assigned that one, because you could have figured out how to use your calculator to do it, and now just solved it by hand. Okay, cool kids, if it's an average rate of change, you can actually just plug and chug, because there will be a delta t, because there will be displacement, there will be a change in time, right? So therefore I could go ahead and say that this would be between t, I don't know, from like A to B, right? So you could do f of b minus f of a all over b minus a, average rate of change, formula from last year. Did we do s of b minus s of a?
Yes.
Either way, it's position, right?
What's the same thing?
Change in position over change, well, when f is position, yeah, that would work. Now, instantaneous rate of change, what's different?
Absolute value of the derivative of position.
Well,
That's certain.
the point is that we're trying to not have a change in time, we're trying to do it at an instant, so we say the change in time goes to 0, right? And otherwise we can use the exact same equation. Hey, isn't this just the limit definition of a derivative? But it also makes sense because it's at one instant, so the change in time is approaching 0.
Greek words just for this.
Now how does that apply? Probably not the limit definition of a derivative.
What about the limit?
Oh.
What about displacement?
That's
Displacement.
So what would you guys do with a rock is falling y equals 16t squared feet in the first t seconds? That's the scenario. How would you solve the limit as h goes to 0 of 16 times 2 plus h quantity squared minus 16 times 2 quantity squared all over h?
Plug in H.
Plug in 0, it's 0 over 0 then.
Derivative.
L'hôpital.
Two options.
The hospitals.
You could.
Actually,
it's not
Do you want to do the hospital?
La Hospital.
The hospital.
Don't say hospitals, please.
La Hospital.
Jeez. Does it?
It's
Maybe
La.
16
Yeah.
times
It's
2
an
squared
apostrophe.
minus 16 times 2 squared over 0. 0 over 0.
Do you really not like hospitals that much?
It just doesn't sound right.
Say Loki.
Just
How
say
hard is
look
that?
at that.
Alright,
But
alright.
it's spelled in hospital. You live in America, we speak American.
Listen, girls.
Okay. Couldn't I go ahead and make it the limit as h approaches 0 of, you guys said keep going, you're technically right. It could be 16 times 4 plus 16 times 4h plus 16h squared minus 16 times 4. Sure?
See.
I foiled. 2 times 2 is 4. Outer and inner. 2h plus 2h is 4h. h times h is h squared. I brought the 16 into everybody. Then what? Those two
Oh, you can
cancel.
get H out.
I can do the h out of the top. And that h on top is going to reduce with the bottom. Yeah, it's going to cancel out with the bottom, right? Now I can plug in h is 0 and I end up with a final answer of 64.
Wait.
What does it represent?
The position of the rock after it falls.
It's not position, you guys know better. What's this? Look
The
at it in
slope.
context.
Feet per second?
This is change in position. What's down here?
Second. So feet per
Change
second.
in time. So I didn't put delta H, but that's what I was talking about. So basically it's distance over time, so what's my label gonna be? You guys know word problems. We label this with 64 what? Feet per second, and what does it represent?
How fast the rock is falling. The first
How fast the rock is falling at,
0 seconds.
no, not 0. Why at 2?
Oh, it's 2 plus 8.
The limit definition of a derivative, isn't it x plus h? But what got plugged into x?
That's a change.
Why?
That's a change in age.
Wait, how did
Why did you choose 2?
So couldn't, well, because 2 is in the column.
Where?
So instead of x plus h, it was 2 plus h. Isn't the limit definition of a derivative f of x plus h minus f of x?
Okay.
But x equals 2. So remember guys, the limit definition of a derivative, we could have back here been like, oh hey, it's the derivative of 16t squared when t equals 2. Which is, what's the derivative of 16t squared?
2t.
Such that t equals 2. Final answer. It's how fast the rock is falling after 2 seconds. Right? Yeah, Corey.
No more.
Where'd you put
I
that?
think you answered it. I don't know this.
Oh, you did the derivative.
Because can't you just do S of B minus S of R, then B minus A?
Because t
Oh,
equals 2.
yeah,
It would have been t plus h instead of x plus h technically. But it would have been t plus h.
Oh, Misty,
Hate limits.
this is instantaneous, right?
Yes.
Yeah, probably is.
And why is it instantaneous? Was I actually calculating a change in time and a change in position, or was I actually taking a limit trying to get infinitely close, infinitesimally close?
That looks really awkwardly long.
It does look long, but is it really that hard? Huh. Limits! Remember, limits form the foundation to derivatives, so therefore, well, let's review everything limits really, really fast. Remember one-sided limits? Okay, let's review. If it's a with a little minus, is that a little bit less than a coming towards a, or a little bit
Going
above a?
towards it.
Less going to.
Less, which means from the left. Man, I can't talk right
It's a dream.
If we already know this, do we have to
Maybe.
write it down?
Yes.
now. It's kind of green. Huh?
If we already know this, do we have to write it down, or can we like summarize?
You can abbreviate, but you need to get, I mean, I already kind of abbreviated, but yeah.
Okay.
From the right? That's the great those technicals.
Because I need.
Two-sided limits. The limit exists if. What was our quick description of whether a
It
limit
is
exists or not?
continuous.
Ooh, that's continuity, not there.
Up, up, up.
If the f of x,
There's no whole break stumps there.
if the one side of limits agree, and the x approaching 0.
Right from the right.
To the right, to the right.
Equals, oh no, as
Limit x approaches 0.
I'm not showing the definition of continuous, but it's very similar. I'm just talking about the limit. The limit as x approaches c of f of x is going to exist if the limit from below equals the limit from above. Does that make sense how I'm using notation to show what I used words for last year?
Yes.
If the limit from below equals the limit above, then it equals the limit, the two-sided limit, the limit as x approaches c. So to that end, you guys ready to practice?
Yeah.
Oh
my god.
Could try dual paging. You guys want to see if you can read it? There's a lot in the next page though.
Wait, Misty. Oh, never mind.
I gave you not only the graphs, but also the piecewise. Wasn't I nice?
Thank you.
E for effort. Huh. Sure.
Do you need glasses?
There's Jason. I apologize profusely. I'll buy you a Rubik's Cube.
Rubik's Cube?
No, just buy one.
You guys showing off your limit knowledge?
Yep. Yes, no, yes. Jesus lives.
I hope that this is like an AP question, like an FAQ.
Wasn't it? It was last year.
Yeah.
Wow. Okay.
But it wasn't a whole question. Wasn't it just like part A or something?
No, but then you have to find, you have to use like, find the areas under it.
Wait,
Oh,
that's
no.
functions in the
The
file.
piecewise.
There's like 5 different variables.
Like K, X.
I got like half of that, right? That was fun.
We've done like that.
3.
Oh, college, you got the SAT subjects didn't you?
Oh, that was fun. 740 and 730 in that too.
Okay, what are the
I made a mistake of guessing. Don't guess.
It's out of
I got like 6.
Yeah, I know, it's not the SATs. If you
I know. No one told me that.
Wait, if you guess, you get a roll?
Wait, you guys got it? It's done?
Wait, so they only mark you for what
Okay.
Yes.
you put down?
Also, no,
Yes.
We must
Well,
be
that's-
done.
no, you miss more points if you get it wrong.
Yeah, so.
You still miss points if you don't put it, but you miss more points if
Oh,
you
you
get it
can
wrong.
keep going.
That's okay.
That would have been useful.
We're actually starting like beyond our
I don't think you have to
polar
do
bear
that.
metric. Do you guys want your letters?
Oh, yeah!
Jason.
Can
Do
I
you want to
George's?
choose what letter you want, or do you want me to just go?
Anyone but G-Rod.
Oh yeah, I just want
George, I want
I
George.
want George's.
I want Georgie's.
Okay, I only have 3 copies of each, otherwise I have all of them scanned and they're underneath letters of advice. You can see
I want
BC
George's.
advice from this year and last year. There were 24 kids 2 years ago, so there are a lot of letters from 2 years
I
ago.
will call George right now and
I
tell
know.
him. I'll call George and he will agree that I should have
No,
it.
the original is
I
black.
am,
The original is
I heard one there.
George left.
I'm doing it in order that I heard. Calm down.
Wait, say
Order that I heard.
Misty,
I
could you
heard
say
a George there. Yes.
I just want George.
I'm gonna rip it in half, make it half.
Wait, what does Joyce
Hers
mean?
is-
When did Joyce
But Joyce is like
I feel like the copy holds so
I mean,
much.
Joyce means genius.
It's all scanned online, you silly goose.
Are we silly geese?
Silly.
Silly goose? I think she needs his advice.
Oh,
Oh,
Okay.
duh.
damn.
Who wants Amanda Johnson? Me. There's one. Pass that.
You're about to raise your hand.
And
George
Syrian.
is opposite pages.
Adeb?
Who wants G-Rod?
Who wants Jackie?
Oh, you did this class like this one.
And whoever doesn't raise their hand, whatever's left.
Wait, Jack.
Pass that.
That's one of the
Jack is in the He's the.
Pass that.
But,
Who wants Joyce Lee?
Okay, let's see. Be inspired to get that.
Her writing. It's like her. It's like
Have you been watching your
it's like actual
Snapchat?
porn.
Any more Joyce Lees?
What the heck? It looks like a computer.
Yes, I know.
It's because Because she practices fonts.
Wait, what?
Wait, Carl, can I see her?
So in her fun time, she practices fonts?
And drawing. So no more
What the heck?
G-Rod.
G-Rod, G-Rod, G. Brandon, get G-Rod.
Alright, you guys get whatever comes.
And that's the first time those words have ever been said.
Did I get the original written copy?
Maybe.
Ribbit.
Alright, who doesn't have one? Raise your hand.
He gives his phone number.
Can I have a different person?
I know.
Why?
Please,
Wait, who are my options?
Please.
You got my letter for this. Hey, Mrs. Egan, how can we find out who got our letters?
Who's Amanda?
You tell us, like, maybe.
Yes, don't drink.
Yeah, that makes sense, yeah.
Wait, we'll see. That
Huh?
this is a yeah. This is
On a switch cow?
Nope.
Dang it.
I don't remember
Did you not do UCLA?
I know she did. Is there any more of Amanda Johnson's?
Why do you want to make
that.
Johnson? Who do you have?
So?
Yeah.
I want to, because I've just remembered, she got into UCLA, so.
Yeah.
She just signed Amanda, so you guys can like switch and read.
I can read it. I can switch.
And you can steal George's.
Yeah, I'm sure her spicy companies up to down the UCLA.
I'll read it.
20 points, that's not big.
Alright, let's go.
Is it entertaining?
Do we get to get this back?
Are any of them funny?
Huh?
Are any of them funny?
George's.
Yeah, I know, besides Georgie.
I'm reading
Gerard's
Gerard's.
entertaining.
Gerard's?
Amanda and Adeb are both useful.
That's
Practical. Jack,
Alright,
they all did
give
good
this
letters
a
last year.
hard time.
That was my letter.
Huh?
AB. I don't remember.
I want to know
I
what's
read it.
on.
I read it like the first day of school. I don't remember.
Somebody got my letter for something, and I forgot
Oh,
what
I
it
keep
was.
this? Oh, yeah.
Who's gone? Ethan's gone.
He started putting song lyrics in here.
Where? Oh, G-Rod?
Gerard's.
What about it?
He doesn't want song lyrics.
Oh.
That is.
I know, right?
I don't care.
We're gonna die in that section. If she had a hard time with this.
Oh, what did I
Which
do to
section
you?
did she have a hard time with?
Lagrange.
But she also took an English class, so
She did, yeah, she was like,
she did French
watching,
and music.
Ignore what
watching
George
the
says
lectures
about
during
bleach.
our CalcBC class, remember?
Right?
Wait,
Wait, can we just take a moment?
But George says don't drink bleach.
George said don't drink
George
bleach.
says don't drink
So
bleach.
he says don't listen to him, so drink bleach. The whole ultimately was being said is true.
George says don't drink
So
bleach.
ultimately you got both sides of the argument like you always got.
Everyone George.
I already have George.
I'll steal that back to the done.
I'm
Alright,
George's
focus,
favorite
go.
person. I'm George's favorite senior.
I'm literally his dog. No, I'm kidding. Oh, wait, that's cute. Wait.
Calm down.
This is taken out of context from yesterday.
Alright, kiddos, here we go.
Does not exist.
They both went to UCLA? Yeah, take their advice.
They're advice, guys.
Yeah, take their advice on calculus, because that's how you get UCLA is only calculus. Because you're going to need a lot more advice.
Wait, George is Gabby has it.
Yeah, you want it?
Yeah.
Okay.
Alright, kiddos, what's the limit as x approaches 1 from below? 0, because if you use the graph, you're coming from below, and if you use the function, what are you doing? Remember, they never give you both, so if you use the function, how do you know the limit is 0 as you approach 1 from below?
Plug it
Which
in!
piece?
Like what, 99?
The less than piece, right? So plug it in 0. How about letter B?
1!
How about letter C?
2! Oops! D&E! I didn't actually read it.
Because remember, you would have to look at both pieces that involve 1, plug into that one 0, that one 1. They do not agree, therefore the limit does not exist. What do I call this point, this x value, where there are 2 inequalities involving it?
Jump.
Separators.
Separate.
Beware the separators.
You are the separator.
Separators.
It will come back.
Beware the separators.
Right.
It's a struggle.
So many seconds.
I have to save the talking well for tonight. Anyway,
Each
the
one.
limit as x approaches 2 is...
One.
What? It's a hole!
But it's still
The
Just
approach!
down
doesn't mean
The approach! The approach! From both directions, the little cars are approaching a diner that is at the height of 1, even though it might have
Why is it
burned
a
down.
diner? Can we change it?
Letter E. What's F of 2?
2! What'd you say?
So, question, is the function continuous at 2?
No.
No, but does the limit exist at 2?
Yeah.
Yes, nicely done. Let's keep going.
2-6 today. Springs are going
Nailed
much.
it.
Dead puppies.
No, Corey.
Pause.
I'll
Pause.
Oh,
Pause.
cliffhanger.
Do you necessarily need to write everything on this page?
Yes.
No.
Maybe.
Right in.
When does direct substitution work for you to be aware? When does direct substitution work?
Polynomials
Wait,
and rationals.
wait.
Yeah.
Radicals and
Any sort of polynomial, doesn't matter. Any sort of rational as long as, what would you need to add as the addendum?
Not 0 over 0.
As long as Q of C is not 0. Any radical, it'll work as long as C is greater than or equal to 0. Good, as long as C is not negative. Composite, you can always plug in, take the limit of the inner, and then plug into the outer. That makes things a little bit easier from time to time. Trigonometric, it always works as long as, well, as long as it is not one of the vertical asymptotes, right?
Asymptotes.
I guess I didn't have to do plus or minus. I apologize. Because plus pi n could go positive or negative. Anyway. So trig is going to work as long as they are not at vertical asymptotes, and you know that hopefully from your basic graphs. And exponentials, it'll work as well, except logarithms. Hey, I'm reviewing domain problems at the same time. What does C need to be?
Positive.
Good.
Greater than 0.
Positive and non-zero, right? Greater than 0. Positive but non-zero. So write down what you need, but you probably don't need a lot. So with limits, we know we always start with direct substitution. Beware of the domain problems though, and if there are domain problems, aka if it does not exist, it's undefined, remember there are different ways to keep going. There are different ways to keep going. If the answer does not automatically occur. Noah, what'd you say? Yes. The video as well as the notes. So, what if a problem does occur? And what if the problem that occurs is 0 over 0?
The hospitals.
Remember last year we had like, I don't know, we spent like 5 pages, maybe a whole day on this? But for us, you can use L'Hopital's, and I am going to go ahead and put that down below because you guys know L'Hopital's is a thing. How does L'Hopital's work again?
Derive the top, derive the bottom, plug in.
If indeterminate, I can go ahead and try the limit as x approaches c of f prime of x over g prime of x. Yes, that's true. Okay? But that's not always what's easiest. Sometimes factoring will be a lot easier because it avoids you having to do like chain rule or product rule or something else. Rationalizing, when would we multiply? Well, hold on. When do we need rationalizing? Yeah, whenever you have a function with a square root in the expression, right? And what's that called that we're multiplying by?
Conjugate.
The conjugate. Remember, it's the exact same term except the signs are flipped. Instead of multiplying, like if you have a plus b, like square root of x plus 2, and they're separate terms, you would multiply by square root of x minus 2, top and bottom. Have to multiply by 1 creatively. And if you have complex fractions or even trig, you might need to simplify. Now, complex fractions, we know how to simplify. How would you simplify trig? Forever card? 1.
Unit circle.
Maybe if it's something where you're plugging in, but trig identities is what's going to be a little bit more abstract because you might not recognize, right? That does not look at identities. Trig identities. Trig identities. Okay? And then, yes, L'Hopital's, of course, we know that's a thing. Did you guys miss what I had over to the side? Remember, if it's 0 over 0, what do we assume it almost always is?
A whole.
It is possible it might be some sort of jump if it's a piecewise function or some other kind of funky function with absolute value or something. The vertical asymptote, hold on. If this is a whole, how do we know? How do we identify? We're finding a limit. How do we remember? Oh, this is a
If
vertical
it's
asymptote.
removable.
No.
Whole is removable.
Bottom is the.
Number over 0, infinite form. This is indeterminate form, right? Stop judging. Indeterminate form. Be considerate. Remember our third B?
What does it be kind, be real, be, oh wait.
Wait, Miss B.
Be,
Be committed,
She just said purple.
be real, and be considerate. Yeah.
What does that say underneath the or?
Identities.
Oh.
Sorry, identities.
Yeah.
Bring cursive back. Should have never been taken out.
No, disagree 100%.
I just hated how we were forced to write it in first and
Cursive
fifth
is
grade, and we didn't
pointless.
use it in middle school
What's
at
the
all.
purpose of cursive?
It's nice handwriting.
Helps things go faster. It's more artistic, so it's kind of a form of art, and it helps you sign your name and not just look like everyone else.
But I'm bad at it.
It's what makes us human.
Cursive makes us
We ready?
definitely not the fact that
My handwriting
are mammals that
Okay,
know.
as you guys noticed, the next one is going to be vertical asymptotes in infinite form. If you want to keep going. Ha! Keep going. That's funny.
No.
Yes, we
Remember, what are the possible answer choices if, yes, there's going to be a vertical asymptote at that point, but what are the possible answers that you have to now consider? Either positive infinity
Negative infinity?
or negative infinity.
Dinner.
Why would it deny if it's a vertical asymptote?
Because they go opposite.
Because they go opposite directions as it comes towards a constant, right? So we have to remember those three, which is why I say check the sign. Check the sign. How far are we from the end?
No,
Wait.
Close. One slide. Okay.
just do
So
it Monday.
listen.
we start.
We're going to section 2-2 tomorrow. We'll probably finish it. Both homeworks will probably be due on Monday. It's your choice
Don't see a book.
whether you finish the homework tonight. But what is everyone's homework tonight?
Start it.
Start. Get out of here. Like this.
Stop being so mean.
I'm not being mean.
Bye. Huh. Yes.